Welcome to Study Loop.
Hello friends, here it is given a thin homogeneous triangular plate of weight 10 pound welded to a light vertical axle supported by the bearings A and B. If initially it is at rest, omega naught is 0, then a couple of moment 0.75 foot-pound J cap is applied. It calculates the resulting angular acceleration of the plate and dynamic reactions A and B after the couple has been applied. Let us start solving it. We have to apply the concept of summation of forces must be equal to MA and summation of torque about A point. Summation of moment of force about A point is equal to rate of change of angular momentum AXYZ plus omega cross HA. So these two concepts we have to apply to solve it. First we will calculate angular momentum about A of the assembly. So omega can be written as omega j cap. So HA will be angular momentum of the assembly about A will be minus Ix by omega I cap plus I by omega j cap minus I by z omega k cap. The moment of inertia of the triangle I by area 1 by 12 b cube into h. Here A is equal to half V into H. I by mass M upon A I by area. So it becomes 1 by 6 mv square. The product of inertia of the triangle is Ix by area 1 by 24 V square H square. Ix by mass M upon A Ix by area. So it will be 1 by 12 mbh along z-axis. I by z mass is 0. Thus moment of inertia, thus angular momentum about A we can write minus 1 by 12 mvh omega I cap plus 1 by 6 mb square omega j cap. Say equation 1. The angular velocity of frame of reference ax by z rotating with plate is equal to omega j cap. So we can write summation of ma, that is moment of force about A, will be rate of change of angular momentum of assembly in the reference frame ax by z plus omega cross ha. Say this is equation 2 from equation 1. H dot A rate of change of momentum you can obtain by differentiating equation 1 with respect to rotating frame. You will get minus 1 by 12 mbh alpha I cap plus 1 by 6 mb square alpha j cap. Now substituting the value, you can write in equation 2. From equation 2 we can write mo j cap plus hj cross bx I cap plus bz k cap. Dynamic reaction at B point is equal to minus 1 by 12 mbh alpha I cap plus 1 by 6 mb square alpha j cap plus 0, since initial angular velocity is given 0. So by solving it, we can write m naught j cap minus h bx k cap plus h bz I cap to be equal to minus 1 by 12 mbh alpha I cap plus 1 by 6 mb square alpha j cap. So comparing, you can write equating coefficient of I cap, j cap and k cap. Rather than you can write unit vectors. So it would be MO to be 1 by 6 MB square alpha. So from here alpha you will get 6 MO upon MB square. Now by substituting the given values, we can write alpha to be 6 into MO is given 0.75, mass is 10 pound, so you have to convert into length is 1 square, so you will get 14.49 radian per second square. So one answer we have obtained. Angular acceleration of the assembly is 14.49 radian per second square j cap. This is the answer of A part. Now we are going to solve B part in continuation with, if we find k coefficient of unit vector k cap minus h Vx to be 0, that means dynamic reaction of x component is 0. I cap, you will get h Vz to be equal to minus 1 by 12 mvh alpha. So from here z component of dynamic reaction at B, we will get minus 1 by 12 mv alpha. Now substitute the value. So you can calculate this value. So Vz you will get minus 1 by 12, mass is given 10 by 32.2, B is given 1 fit, and alpha we have measured 14.49. So this value is minus 0.375 pound. So dynamic reaction at B point you will write minus 0.375 pound K cap. This is the one answer of B part. Now we have to calculate dynamic reaction at A. Now we should apply summation of F to be mass into acceleration. Since omega is 0, so A will be only tangential, that is alpha j cap into B by 3 I cap. There will be a cross product, remember it. So it will be minus 1 by 3 V alpha k cap. Now resultant force, summation of force, so A force plus B force must be equal to mass into acceleration. B force already we know, A we have to calculate. So A is equal to minus 1 by 3 V alpha k cap minus B. So minus 0.375 pound k cap. Now calculate this value. All the parameters are known to us. 1 by 3 V. Here I forget to write the mass. So here mass will be also there. I am correcting a little bit. Minus 1 by 3 mb alpha k cap. Now substitute the value 10 upon 32.2. Alpha is 14.49. This is your K cap minus plus 0.375 pound K cap. So on solving it, value of A you will get minus 1.125 pound K cap. That is the answer for this problem. Thanks for watching it.